Good afternoon, everybody. We're going to go ahead and get going. We got a few people online. Thanks for showing up, everybody. I know the weather's kind of crappy out there today, and Thursdays are always a busy day for everybody. So we'll get rolling on this. So we put together this presentation on UV and ionized air, and Brian Skip is going to be presenting. But like any other meeting along, we always like to start off with a little bit of safety. And today, given the COVID environment we're in, we're going to watch a video on washing hands. And as simplistic as it sounds, this is about the duration in which you need to wash your hands to thoroughly get them clean. And as the case count drops here in Alaska, we definitely want to make sure we're doing everything we can to help support that. So we'll watch this video real quick. Seems like it goes much faster now when you're actually in the bathroom, doesn't it?
I'm sorry, but I'd already have to pee again.
All right, so before we get started, a quick word from our sponsor, Long Building Technologies. A majority of you obviously know who we are if you're here today or if you're online. But if you've been working with just maybe one of our business units, such as HVA Service or our Building Automation Group, we also offer security solutions as well as the supply of HVAC.
New one.
But we also have a parts pro department, which we have access to over 1,000 vendors offering parts for any one of our business units there. Sorry about that. We'll go ahead and get started. Again, this is Brian Skip. He is our local expert on UV and ionization. We'll let him get started.
All right. Thanks for coming out, everybody. So we're all in this business together. We need people in our buildings. That's just the reality. How many people have been working from home throughout this hybrid schedule? You know, kind of a mix in and out. That's just what's happening. And people are going to be occupying their buildings here soon, hopefully, rather than later. They'll be occupying their buildings, and we want to make that transition smooth, healthy, and safe for the people going back into work. Some of the things that we can do with that, evaluate as we go back into buildings. Hopefully, if you've been there the whole time, your building's up to snuff. But going back into buildings, you need to evaluate mechanical and life safety systems. You guys have seen it. How many times you go into an air handler room and everything's disconnected? It was a temporary fix 10 years ago. Outside air dampers are disconnected. Return air dampers are disconnected. You're not bringing in the minimum. That stuff needs to be checked and addressed, so you can get the minimum outside air, and really they're asking for more air changes and that anyway. So ventilation systems, increased filtration. It's recommended to go up to a MERV 13 filter. A lot of people are talking about a MERV 16 and HEPA filter, but MERV 13 is okay without changing the fan configuration, worried about pressure drop. So we recommend doing that, and also consider UV supplementation and air ionization in systems. That you know, you all see face value stuff. Everybody wear a mask. Everybody wash your hands. But there's things that we can do behind the scenes that make an environment safer. And Chris, do you want to go over some of the operational safety things?
Absolutely. And also, I did forget to say, if anybody has any questions or commentary or anything like that, please just speak right up. We can keep this as interactive as you'd like it. And even for you online, we have you dead center of the room and volume's all the way up, so we'll be able to hear you loud and clear. Hopefully you can hear us as well. But we've been following AGC's guidelines since March of last year. they seem to move right out in front of the crowd, and we're kind of leading the way, talking about operational reactions to COVID. And so the modification of workspaces, making sure that coworkers are 6 feet apart or have a barrier in between them, that the desk position in the room somewhere between the return and supply air, so that we got some really good circulation going on in there. The stay-at-home and sick policy, so even if they just have the sniffles and it even remotely looks like COVID, then they just need to stay home. And then if they have 2 or more symptoms, then they need to go ahead and get tested before they come back to the workplace. And then, of course, the washing of the hands, which we conveniently provided you a video just a few minutes ago on how to do so. But if you're looking for some guidance on that to make sure you're staying up with it, just do a search for AGC COVID on Google, and it'll get you right in there, and they'll have all the updated guidelines for work.
And I know a lot of you guys in here have seen the different changes they want in designs and stuff like that. More air changes, more outside air being brought in. UV, you could add UV and ionization to air handlers. There's just a lot of different things we can do. We could tune control loops, make sure our control system's functioning properly to give the adequate supply air. And also in that, the increased filtration, we can up our filters as much as the manufacturer will let us, MERV 13, MERV 16, or we can reconfigure systems, add VFDs in that to use HEPA MERV 16 filters. You could go to a MERV 13 without really worrying about pressure drop or fan reconfigurations. Repair, like we said earlier, repair and fix outside air, return air dampers, and purge the building more often. Up here in Alaska, we know that outside air is expensive. It's really expensive. So things you can do is add UV ionization to limit that.
On that previous slide, it said for schools. Is that really just for schools?
No, that's not just for schools. That's, schools have so many kids in one classroom. The occupancy is really high. If you've been around kids, you've had kids yourself, they come home, they got all the new snotty nose and all that. So that's kind of a rule of thumb. Yeah. UVC lights, if kind of some history, what is UVC, germicidal UVC lights? You hear all different things thrown out there. UV lights, air purifiers, it's the new thing. You see them at Lowe's on the shelf, and it's just a filter thing that's pulling, that has a filter you put in there. So you got to know what they're talking about. That language is kind of thrown out there a lot. UV has been used over 40 years in the medical field and disinfecting rooms and that. And it reduces 99% of viruses in 6 seconds with a dose of 5 mj/cm2. Now that's really important for sizing these systems. That exposure for 6 seconds is really important because airflow moves through air handlers and ducts at a fast pace. So you need to size correctly off the CFM and where you can fit. CDC also recommends upper room systems, and the upper room system's a bit different. Like in this room, it'd be placed throughout, and it shoots a UV field up towards the top. A lot of times it'll catch supply air coming in, and you sneeze, you cough, hot air rises, the nasty air is kind of above, spreading from person to person. So they recommend UV upper room systems as well. Any questions so far or comments? And here's a slide that says the typical LD dose, the 90% lethal dose for viruses all the way to fungal spores. And you can see we're in a good position with COVID as it takes the lowest dose to kill viruses. But that's kind of the full gamut on what it can kill. UVC wavelengths are typically between 100 and 300 nanometers, which inactivates microorganisms. Radiation kills DNA or RNA and kills or deactivates the microbes. Varying doses of UVC radiation are lethal for different organisms.
What dose do we recommend here, Lance?
Oh, well, usually in an air handler system, it's such a high dose because the air moves at such a fast pace. So we base it off. First, we need to go get some calculations, see what the system is. We send that off, and they come up with the adequate lighting that can expose for 6 seconds, but it's a high dose.
And we need to worry about the use and all that as well.
Not so much. It depends on where you're at, like Florida, different places that have high humidity or the environment, like grow facilities and stuff. Yep.
Right.
It's all kind of application specific. This is a typical installation. You see here, the air handler is open. This is our preferred installed down low, where the UV lights are installed on the coil. That's for a couple of reasons. The coil does slow down the air, and we can catch it right there. And it also keeps those coils clean, free of bacteria and mold and stuff. So it kind of does a 1-2 punch there. Up here is installed in the ductwork. I know we've done a lot of those systems where there just isn't room. I mean, a perfect scenario, you open it and you got all this room and you can install wherever you want. But that usually isn't a lot of room. So you got to look at other places. We've done those quite a bit in the supplier return air. Right here, this is really important. This is a shut off, and you need that close to where you open the air handler. UV lights are pretty dangerous. They can burn you. They can cause temporary blindness. Here's a few samples of what we'll put. You'll have one kind of on the shut-off switch, and you want these stickers all around everything, maintenance staff trained. And this is really important here. You put your date of install and times you change your lights. These lights typically last 2 years, 18,000 hours. So you want to be sure you change them every couple of years or they lose their potency. And here we got some case studies, and there's a reference page at the end of the slide, and we could send that out. And it has a lot of these case studies that this stuff has been studied and peer reviewed that you can refer back to. Here's a couple of installations we've done across town. This is a tower downtown. The return air there, we got 6 lights, 2 on each, going across. Something you do have to be mindful. See, we have about 4.5, maybe 5 foot between these filters. This stuff will deteriorate filters. We've learned that the hard way, where we were about a foot away from MERV 13 filters, and it turned them into dust, literal just dust. So we had to put reflectors on that system. We try to stay away from reflectors because a lot of times that limits the airflow, but they'll come in like a triangle or a circle piece. So depending on where you're at, that kind of, if you're kind of limited on space, can restrict airflow. But this will decolor, change the color on that. It's like a sticker you put on your door. It's in the sun all the time. It'll lose its color.
Is there a set distance, or is that going to be dependent on how many lights or how powerful?
Yeah. Yep. You still don't want them really close to MERV or filters, filter media. There is some concerns on if you put it in the blower section with belts, exposed belts if they're close. I know we've in the past either built a fan guard or belt guard, something to block off the rubber and stuff that can be deteriorated. And this over here is a system we installed. It's a small ionization system that's just installed on the supply air ductwork. And some things to think about. Make sure that you are using recommended safety protocols. We talked about the safety stickers. We'll also put UVC rated safety goggles close to the air handler, so they're right there. If maintenance staff comes in, has to open it up. That's really important. Make sure everybody's trained on the dangers of UVC. Light saturation must be high enough to ensure microbes are deactivated. That's really important with sizing of the system. You can't just stick a UV light in there. It has to be the proper dose for the CFM in space, how fast the air is moving through there. So that's something we'll come out, take a measurement, see what's going on, look at the drawings, look at the CFM, and send that off to be sized up from the manufacturer. No-touch automation eliminates human air and disinfection. You all seen the UV wands that you go around the building. This kind of just passes through. And another thing to think about in this slide, Chris mentioned it one time and it really stuck with me. These 2 type systems, UV and air ionization, are a passive and active system. He compared it to a security system. You have your camera up, the guy comes, robs your car, you've seen him do it, but he had to walk past the camera. That's a passive system. That's like UV lights. The viruses and mold have to pass through the air handler to be inactivated or killed. So air ionization is like a burglar alarm. The burglar alarm, you break in the building, the burglar alarm goes off, it calls the authorities, the cops are on their way. That's an active thing. That's like compared to ionization. It's in your ductwork, but it goes throughout the building and is an active system.
They work best together, right?
Yeah, they work best together. They could work alone, but they work best together. Camera, cops get there, you have footage to hand over, you know. So they work best together, but they can't be independent. Air ionization systems uses high voltage to electrically charge air molecules. It's proven to be effective reducing airborne contaminants, reduces 99% of COVID, 95% reduction of ultrafine particles, and 90% reduction of VOCs. The CDC recommends upper room systems to combat infection, specifically air ionization systems. They make kind of a similar thing to the upper air UV. They make ones that would go inside the supply duct, right past in there, and then that's kind of an upper room ionization. How it works. So we have our polluted return air coming through the ductwork. Wherever you have installed your ionization system, it's negatively and positively charging these ions that get released into the workplace, into the space. Ionization begins and it starts attaching to particles and bacteria and mold. And that lasts 45 minutes. The ionization that's released into the space is alive for 45 minutes.
What's in here?
Yeah, you can smell it. So I personally like the smell, kind of crisp air. But some people can be sensitive, but they can be sensitive to smells. You know, somebody comes in with cologne, they be sensitive to that anyway. So I like the smell. It's similar to a new car smell. You know, it's crisp air.
Similar to ozone generation.
This doesn't generate any ozone, but some people have compared the smell to ozone, like a light ozone generation. But this bipolar ionization doesn't generate ozone.
Ultraviolet.
Yeah. And then how it works, COVID specific. So we're talking about the negatively and positively charged ions. They're introduced into the air through the duct, and they create OH, or OH radicals are formed when ions attach, and when the ions attach to the proteins that protrude from the membrane of the virus, they attach to the outside of the virus. The OH radicals steal a hydrogen from the virus, then return to the air as water, leaving holes in the membrane. Then they're destroyed, and a lot of times, another thing, good part of this is, you know, COVID is really, really small. That's why the mask mandates and mask debate is so heavy, because COVID is so small. Something that this also does is it connects to viruses and grows it, makes it bigger, like a conglomeration to that. That helps a MERV13 or MERV16 filter catch it as it's filtered out. It also will kill it, drop it, and a lot of times it gets vacuumed. You know,
As a reference, I get some information because the visibility threshold for the human eye is 10 to 40 microns. And here, for reference, is 50 to 180 microns. So the virus is 1/10.
Yeah. So it's so tiny, and that's one thing it does. It actually, when it connects, it actually grows it, makes it bigger, and able to filter out more.
This water coming on, does that affect humidity? What's the water about?
No, it's just it's the natural water that's already in the air anyway. So it doesn't add humidity to the air. And here's some samples of some installations over there. So that's right there before the coil. A rack is built. Rack's built, and it kind of sits like this, so some air can kind of get behind it and travel through. There's in some ductwork installation and some ductwork there. Some more peer-reviewed examples that will be in the reference page. Things to think about, especially here in Alaska, reducing the outside air requirements by up to 50%. No pressure drop. It's not a large thing we're adding to air handlers and systems, so we don't really have to worry about fan speeds and pressure drop. And they're really efficient to run. They really utilize very little power.
22 cents a kilowatt hour, that's pretty important.
Yeah. Yep. Was there any questions or anything that you guys want to touch on or ask some questions about?
Brian, just a quick question there. Obviously now with the CDC requirements and obviously COVID-19 response, a lot of facilities have implemented SOP, obviously response of that. We do sanitation, you know, for classrooms.
Yeah.
Obviously now you refer that the UV lighting is affected with filter, right? Because of proximity to that. So there's anything established or anything that once we use, you know, like foggers for sanitation process, how it's going to affect that UV lighting, how it's going to affect the filters. I mean, obviously we don't know that.
Yeah.
Until we implemented those systems, right?
Yep.
Do you have any information whatsoever how that will interact correctly or how that will affect?
Yeah.
Because this is going to be, you know, reflected on maintenance operation.
Yes. Oh, yeah. Okay.
Yeah, the process we do nowadays, all facilities and on doctors, it's going to affect on how well they're played.
Yeah. So if, I guess the question, so what's the cost of like ownership over time?
There's nothing right now. You just
Yeah.
mentioned that, you know, UV lighting, it will affect the process, right?
Yep.
I mean, we didn't know that in the beginning when we established the systems, right?
Yeah.
Now as a facility, we're implementing sanitation process. We use a lot of foggers, chemicals, and everything.
Yep.
How that is going to impact to our lighting or any other type of filtration that we're going to have. We don't know that.
Yeah.
My point is, we don't know that.
Yep.
Obviously, it's going to be reflected on maintenance operation.
Yeah. Yep. Yeah, and increased filtration. I mean, now they're recommending changing filters all the time. The more outside air we bring in, the filters are dirtier. So it'd be a good thing to force the hand on some operation. I mean, you know, in some places the filters are dated 2016, so might be good to force the hand in some cases like that. But yeah, the verdict is out on what operational.
And so I mean, ASHRAE, it came out almost immediately when this whole thing kicked off, talking about bringing as much outdoor air as possible, right? And especially through spring and summer last year when it's probably a little lesser expensive than doing it in more mild climates. But that's they're saying, just open it all the way up, bring in as much outdoor air as possible. And well, no, that's not really the recommendation because the energy cost, right? The first thing I thought when I saw that was, hell man, we spent 10 years trying to figure out how to adjust for energy costs and trying to whittle that down. And we just threw that out the window. So this could help. This could help be an answer to that, right? Instead of keeping those outside dampers open all the time, which is really inefficient in Alaska
It is.
and in southern Florida. You know, it's a horrible idea. So you know, this might help.
Comment on the ionization. See those variable refrigerant systems where they bring in a minimum amount of outside air, cold bugs and all that for the building. That's where this comes into play pretty well too, because you don't have as much air, so now you're distributing stuff. It's an active system, you know what I'm saying? So as it gets into the spaces, it's doing it. You can't bring all that outside air into those variable. Call it up. So this helps with that. We're actually doing this in some projects in Juneau where we're refrigerant system and we set it for the ionization. That way it is.
I have an online question here. How do these systems reduce OA levels per IMC ASHRAE 62.1? What factor does it change?
So I will have to, there's a reference right here. It does lower the outside air requirements if these systems are added, but I'll have to look in here specifically where they write that out.
Which one were you playing? Or no?
Well, that's the question I have.
Yeah, that's what I have
So with regard to these systems, you know, everybody wants to think they're safe, and you know, listen to Curtis. You know, the size that there's nobody that's going to ever see those molecules, and there's only one person I know of that says somebody's safe, and that's Dr. Oz. He's on TV, but if somebody came to me, I don't care what I did to a system, I would not be inclined to say anybody's safe from anything.
Yeah.
With something that I can't see. And so I'm wondering, what do you tell an owner with regard to, you know, to make the decision to spend the capital on one of these systems. Exactly how safe are they?
Yeah, I think it's about mitigation, right? Because you're not gonna get rid of all of them. And the numbers that were spouted up there, all of them came from these studies here. And a lot of these are independent agencies. ASHRAE is one of them. I think ASHRAE actually has several of these studies in here. And then you go to Atmosair, and Atmosair's got 15 studies from independent organizations utilizing their equipment, right? So the numbers that they're drawing from that are based on lab studies or facility studies, wherever, when they were actually taking measurements. And I think telling anybody that they're 100% safe from anything is a little naive, right?
More safe is a better word.
More safe for sure, but risk mitigation and feeling comfortable in your work environment that you're not walking into a cloud of corona. You know, the airport put up signs right there where you're going through security at TSA here in Anchorage, telling you what the air quality is. And it's a really raw good, you know, and it's bright green and makes you feel good about where you're at. I would argue that the studies that they're doing here, they're publishing it, they're putting their name on it, they're doing the signatures, and it's not just manufacturers, they're independent organizations that are evaluating manufacturers. They're putting their name to it, that they're probably pretty valid, and running up into the 90th percentile is probably pretty good. And again, you're not going to get to 100%. Just, I think that's impossible.
The other question I have is with regard to the application of these devices. So you guys are, I would think you're doing it as a retrofit,
Yes, absolutely.
where I have the opportunity to make it, you know, a basis of design. So, you know, who are those manufacturers that you're using? They have recommendations with regard to, you know, let's say an access section downstream of a coil. You know, if that's the place to put it, you know, in design, you can account for that. Whereas you're settling for less than optimal situations when you're doing it after the fact. I have an opportunity to do it.
I'm wondering if manufacturers are gonna start adding these as an option.
That's also worth too, in the AEQs,
Modular
RTUs,
fanning.
and so forth.
A UV option, for ionization option. for the fan.
And the manufacturer of the lights do recommend right there downstream of the coil, like you said, right there on the face of the coil. However, you know, sometimes that doesn't work, but if it could be designed into it, that's where you'd want to do it right there on the face of that coil, cooling coil, just so it helps keep it clean as well.
Air handling equipment is so modularized right now that you have a module for everything.
Absolutely.
Yeah, just be a slide-in section. I think that reference down southeast here, that's a 10, 12 box. This has all been incorporated into the job, design it to have the station. It's not a proper branding job, so they're
Did the engineer do it, or did the manufacturer of the
doing
fan
the
system?
engineering and the manufacturer
Okay.
together, and
Unfortunately, you got companies like Long who like to do a grow-in-place type installation. These things look like they were built right in the data manufacturer. And I've seen, I personally seen it, a lot of the pictures these technicians bring back, and they are super proud of their installations. They literally look like they were installed at the IBA industry.
The other thing is, you know, for medical, quite a few medical applications where you have to have downstream filters of coils. And so would UV take the place of that requirement downstream, or how do you separate UV from your downstream filtration? Let's say an operating room, you know, something that requires invasive procedures.
yeah, that would be, we definitely have to give it to the manufacturer on that to see where they'd want that placed in line there. Yeah, you should have the HEPA filters. Have that away from it somewhat. And I have seen a lot of it is medical do that upper room UV, or like right inside of the supply, they have little units. I know you've used those a couple of times where they go on the outside of the ductwork and slide in at the supply trunk.
And if anybody has any further questions, like I said, Ryan's a local expert. If he doesn't have the answer, he knows where to find it.